Hello everyone, this is week 6. Today we're going to review the changes to separate access theorem, update game objects with the tag variable, review onCollisionEnter and how that works, and then explain terminal velocity, which we didn't have a chance to do in class. But let's first explain terminal velocity, because that kind of comes with the game, so it works. But as you see currently, when we have the game and we just run it, what's happening is that our position or our terminal velocity is so high that when we rest on it, it's still gaining gravity and increasing velocity. So what we can demonstrate this by doing console.log this dot rigid velocity dot velocity dot y. And when we inspect, we'll see that as we continue to go up, our velocity is still increasing. Well, that means that our change in position is also still increasing. So what's happening is it's saying, hey, we continue to apply greater and greater gravity, which then means greater and greater velocity. Well, that means that we skip this entire thing so that collision never happens. It's kind of bad intuitive. This is kind of hard to intuitively see because it is physically there, but you're moving so fast that you literally phase through this object. So say your position is right here and you move it to right here. Well, in our update, we do collision here and then we do collision here. We don't do collision, or we don't see if we're colliding anything between the two things we're moving. That's kind of the issue that we have. So the only way, not the only way, but the main way to do that is we just update our terminal velocity, and then it prevents us from dropping down. This is kind of very important to kind of our collisions, because if we didn't have terminal velocity, we would just fall through everything, and we'll be able to walk through everything. So if you're having issues, something like this, either your collision isn't working or you just need to update your terminal velocity. The reason why we can kind of do this, though, is because of our changes to our collision. So now in our collision, instead of returning true, yep, there it is. So we can do that. So instead of returning true and false, what we do is we kind of use the JavaScript's, I don't know, what would you call it, but a JavaScript to kind of make this way easier to actually see. Because with our separate access theorem, well, we actually find how much overlap two objects have. It's just we don't know the direction and that stuff. So the way we do this is we need to so first we go through here and we obviously do our separate access theorem, and we return false if they're not in collision. But if they go through this, then they are in collision. So what we do is we get the minimum difference between the two of all the projections and all the overlaps of the shadows. We get the minimum, then we get the index of that minimum, and then we find from that index we find the line, the overlap specifically of that minimum difference index to then return it. What this means is that we will now have a vector 2 that let me double check, isn't mine's yeah, we'll have a vector 2 that kind of describes how much overlap two objects have. And then what we can do with that is that inside of our scene.js, we can use this by saying, hey, if it has a collider, which means that we want to know collisions on it, we loop through all the game objects, and we say, hey, if A and B are in collision, then we get the rigid bodies. But remember, this response variable can either be false, which would say, hey, skip this if statement, or a valid vector 2, which would say, hey, since this is a valid vector 2 or some number, we can say it's true. It's kind of a weird thing about some languages, is that if you just put like n in there, it's going to say it's true. I think. But now we say, hey, if A has a rigid body component, what we can do is we could say, and then we get the response that vector 2, and we have to make sure that it is aligned, because when we do the separate axis theorem, there's two ways to draw the line. You can either draw it towards like the left, so say you have two squares. Say we have this, and say we're trying to determine collision. You can either have a line going this way or a line going this way. So we kind of need to adjust for that and make sure that the dot products go in the same direction, or the dot product of the two vectors go in the same direction. So if it's less than 0, then we know that we need to multiply it by -1 in order to do so. And then on our next one, then we say, since it has a rigid body and they're in collision, we just call onCollisionEnter if they have it. And then we filter for mark for delete. This is kind of the main changes to separate access theorem. And then the final thing I wanted to talk about was our in-class game with laser control. Nope, not laser. It would be triangle controller. Yep. So now here's an example. Is say we use onCollisionEnter with other. We first get the other.name to get it, and we get the laser game object. And if it is the laser game object, then you destroy it. And for our rectangle controller, it's something similar, but with triangle game objects. Now, this kind of is okay for now, but there's a couple of issues that can happen with strictly only naming conventions. One specific one is, say I have 20 enemies. I mean, I don't want to have an if statement that has if enemy 1 or enemy 2 or enemy 3 or enemy 4 or enemy 5 or enemy 6 or whatnot. So one kind of common thing we see is that in our GameObject.js, if we have a name equals no name, there's also kind of the tag equals no. And now we have a comma tag, which is optional. Okay, how you do an optional. Yeah, let's just do this then. Then we can say tag equals no tag. Actually, no, we could just do tag, and then we can say this dot tag equals tag. And now what this can do is, say we have 50 enemies types. Now all we can tag them all as enemies, and then when we're in collision time, we could just say, hey, if other dot tag equals enemy, then we do a response of a specific enemy. And then you can even kind of go even more in that, and you can even say an enemy, all enemies have a variable or a function named, I don't know, damage. And then it gets the damage of it, or something like that. And then you can kind of build off on that and then kind of expand on it as well. So kind of tag is a very kind of important feature to simplify a lot of kind of collision resolutions and that stuff. Another good example would be bullet types. If you have enemies don't spawn the same bullets usually, like at least how I've done it in the past, like enemy A does enemy A thing and enemy B does enemy B thing. Obviously, enemy A and enemy B's like actions are different, but in a sense they do the same thing of either damaging character or making it harder for the character. You can now just enable it as enemy bullet or just bullet. And then whenever the bullet touches, it damages. Like stuff like that can make it a lot easier to do collisions um, and simplify those if statements. I think that's it for review. So I'm ambitious today with what we're gonna do. Um, but, so as you saw, we have our platformer and we have a jump. We have a very basic layout. A lot of this code was from day 11. Um, but we want to expand it and do a double jump and have a health bar. The two kind of key, not key important features, but good features to have if you want them. But they can be a little difficult. So let's first do double jump because we already do a single jump. One way to think of this, or the initial way many think of this can do is do can double jump equals false and do something like this. And then you can say, hey, if air dot up and then you do something like and you can't jump, but you can this dot double cut jump. Then you apply your negative velocity, but instead of it would be minus equals velocity. And you would say, hey, this dot can double jump equals false. And this dot can double jump. Boom. Many people think this, which is intuitively correct. But if we actually go run the game, it's going to be a little bit different. Let's do this so I can show you my inputs. And then let's remove printing out the. Okay. See, I click double jump, the double jump, but it's only jumping once. Well, why? Well, what's happening is in the frame, we say, hey, this is false currently. And we only, well, no, sorry, one more thing. We need to do this. If we interrupt, then we can say, hey, this dot can jump equals false, this dot can double jump equals. And then we set it to false normal. We can go back to the other way because I think the other way is more intuitive. But basically, what's happening is that when you jump, you apply the velocity. But when you jump again, you don't really. It's impossible to jump again because of how we have it. It only turns to false. It only turns to true if we're in collision, and once we're in collision, then it can't be false and true at the same time because of how our if statement or of how we currently assign it. So one thing to do is kind of refactor how we kind of do jumping, which will require some adjustments to our input, but it will be, I think, relatively simple, more intuitive. Rather than saying, hey, jump one, jump two, jump three, what we can do is we can have jumps left equals 0. So now rather than saying, oh, if we can jump, this jump, this jump, this jump, we just do a limited number of jumps and we can go from there. And then what we want to do is then we can say, let's also get rid of the jump stuff. We want to do the if statement where we say, hey, if input dot keys down includes arrow up and this dot jumps left is greater than 0, so we can actually jump. What we want to do is this dot rigid body dot velocity dot y equals negative this dot jump velocity and this dot jumps left. And we still have our falling speed cap, and then we still have something, and then we need just this to be this dot jumps left equals 2 if we want to have 2 jumps. All right, so this is one way of doing it, but we still have an issue. Where is it at? Let me double check one thing. I think our collision. Okay, I don't fully know what has happened. What? Let's try this. I think we need to adjust it to be times 0.5. And then the other top needs to be nope. Okay. That is slightly weird, but it's not working. If input that console dot look this dot left velocity this dot rigid velocity. It's what was our jump stop? I'm just debugging to make sure that everything is working. I think they're working. So yeah, that's the issue. Maybe we don't have to times 0.5. So other transform the position line. Oh, that's jump velocity. Okay, so we're still kind of, now here's kind of the second issue of what's happening is that when we jump, we apply jump twice. If we hold down the jump, it's basically saying, hey, two back-to-back inputs of arrow up and jumps is greater than zero, so we just bam, bam. And we don't want that. We don't want to hold down and kind of have that infinite jumping ability in the sense that it doesn't look right, and it's also not really applying the correct idea of what jumping looks like. Because when you jump, you expect one arc, then a second arc. There's going to have to be a change we make in our input. And this is kind of a very simple way to do it, and it will be done better later on. But the whole idea is keys pressed. With keys pressed, it tracks it per frame. So rather than having specifically what was pressed this frame, rather than what is being held down. So if you hold if you hold key down, what's happening is it's saying, hey, hit it every single time or make sure it's there. Well, in this key's press, if we hold it, it will send it the first time it's down, but it will also kind of, what's the word? It will be removed when we, on the next frame. Um, the best way to do this probably is actually printing it. So we can get rid of these. Let's do console.log input input dots keys down input dot keys press, and we can kind of see the difference. So both are of it, but when I hold one down, you see how now it's alternating every other one, and what's happening is it's saying, hey, you're still holding this down, so keys down still happens, but keys pressed is like, hey, it's not pressed this frame, so we're not going to do it. So what we can do is instead of using keys down, if we use keys pressed includes, what will happen hopefully now is that jump should work. Jump, jump. See? So now you have to specifically jump a separate, you have to intuitively hit the jump button now in order to actually appear it. So now we can jump, jump, um, jump, jump. And if you have a level now, you can kind of do all you want with your double jump and say, I want triple jump. Now I can just do 3. Jump, 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 jump. Wait, 1, 2, 3. So it's not doing 4 though for some reason, which I don't fully understand why. I do 2. Can I do 3 jumps? Okay, so it's not counting the initial jump. Huh. So I wonder why that's. I do that. And now it could just, you could just make it so like, hey, if you do 1, so rather than rather than doing this that jump stuff, you could do extra. jumps left. And then one jumps left, and two jumps left. So now if you have this at 0, you can not jump, but if you have it at 1, you can double jump. That is so weird. Let me just change that because that's not how it's supposed to work. I know the issue. I don't know how to solve it. So what is basically happening is that update your when you press jump, at least I think I know the issue. So say you have 3 jumps and you press up and you press jump again, have 2 jumps. These should only be 3 actually. 1, 2, 3. So basically what jump select is doing is how many jumps outside of your initial jump. Not, I don't understand why. Okay, let's do this then. So jump select is now 1. Okay, so I think the solution I was trying to not do is just what I'm going to do, I think, is greater than 1. Doesn't make sense to me. And now if you want, so now if you only want a single jump, then you could do a single jump. Now if you want double jump, I think you could do 1 for no jump. And then, so this is kind of, there's probably a better way to do this now I think about it. But now you have, this is kind of a very simple way to do triple jump. And now if you want to do quadruple jump, let's try and do it. You could increase it. What I will do is in next week's video, I think I will take another crack. As of right now, this should be good for mouse. 1, 2, 3. Oh no, no. Jump stuff equals 0. Collision you should equal 3. Right. So yeah, what I'll do next video is I will try and debug this, and I'll see kind of what it's a conceptual issue somewhere that's happening. But I will kind of see what's happening. The next thing I want to do was a health system. Might get a little complicated. I'm just trying to think. Oh, another thing. Inside of our engine.js, you have to call input.keysPressed. Inside of our game loop, this is the temporary solution. This is so that inside of our input, we call keys pressed to reset what keys are pressed. Again, this input is a temporary solution, and we will be doing a more expansive input where it's a little bit more structured. But I just kind of wanted to get that idea across on this core concept across. So the next thing we should do is we should create a health yeah, we can do this way. Okay. So we want a health bar game object.js. This is class health bar. We're doing a health bar next, so that you could do health stuff. For a health bar game object, what we want is we want a constructor, and there's kind of three variables we want. We want some sort of game object, probably the better word, that we want the health bar attached to. We want our max HP and our current HP. And what we can then do is we could say super. We won't need collisions, so whatever we put in the super doesn't matter. This dot add component. And we want to add this new health bar controller. And we want it so that the entity, let's do game object as game object. Max HP is max HP. And then current HP is current HP. And we want to set the scale. So this dot transform dot scale equals new vector 2, 30 in the X and 10 in the Y. So now let's add the health bar controller. Yes, class this component. Now health bar controller, what we need is we need the game object. So just to let you know that, or kind of clarify, we need these variables, game object, which we have, max HP, and current HP. And now this is kind of more of a conceptual where we want offset Y, and let's set that equal 20. That's kind of the thing I've found. So for an update, all we want to do is do this dot health percent equals this dot. We want to recalculate the health percentage. And then inside of it, and the main thing about this, which is weird, is that it's specifically a draw kind of game object or component per se. We don't normally do draws. Two things to note here. Since we aren't doing collisions with our health bar, and since it doesn't really matter the points per se, and so we don't have to worry about the vectors and points or even circles, we could use stuff like rectangle and arc for circles, because the only thing that the only time where we want to know the points is that if we want to know collisions. So this is kind of what my idea is anyways. We do const x. We want to get the x game object transform dot position dot x. this dot game object. Oh, this is why game object is. Let's change it to entity. Okay, so now with entity, so the reason why I changed it from game object is we already have a game object variable, so that could get a little bit messy. But what we want to do is we want to get the position of what we want to attach the health bar to, and we also want to do this dot offset y. And what we're going to do is we want to fill an initial rectangle in the background as red. Look, we need to add a context. Context. So we want to do fill style equals red. And then this is what I was talking about, where it's like we could do the point two, but I found it easier to do fill rectangle for this specifically. Again, this is probably the best way to do it, at least most logically for me, because points for this can be a little bit weird. But first, so what we do is we take our x, which is our current entity position, and we move left of our scale so that it is centered. And then in our y, we just use our y because that's the value we want to be centered at. And then we want to scale it this dot transform dot scale dot x, and we want to scale this dot transform dot scale dot y. So this will be our x position, and then y will be our y position, and then we scale it based off what's it called? Yeah. But now we do the exact same thing, but with green. Now if we do green, what's going to happen though is that we need to actually scale the x transform dot scale to times it by this dot health percentage. What this will do is it'll say, hey, we can also do this as well. We can assume health percentage is 1. We say, hey, let's scale it. So if it's 0.5, it should draw halfway towards the entity or the health bar. So it should fill up halfway. And then the other thing that I like is just CTX dot. This is stuff that we don't really talk about in class because we are switching from this built-in CTX like rectangle to CTX dot, what's it called, to line 2, but this is kind of the final thing. Where we do pretty much the exact same, we just do an outline of this rectangle. Oh, and then we need to add it. Okay, I'll kind of review this because this is kind of a unique game object for most things where we only draw. So we get the current X and Y position based on, so first we fill a rectangle with red. That will show how much health we've lost. And what we do is we get our X and then we minus half of our scale to get the far left edge of the rectangle. And we also get the Y, which is the bottom left. And then what we do is we scale in the X and Y so that it scales correctly, based off of what we have inside of when we instantiate the game object of 30 and 10. Then for green, what we do is we do the exact same thing, but we times it by our health percentage. And this goes from 0 to 1. And what happens is that, say, for example, if our health is at 0.5%, we scale the rectangle in the x direction by half. This will kind of allow easy kind of scalability between 0 and 1, where 0 is 0 health and 1 is our max health. And then this is just a black border that's optional. Nothing too crazy on that. All it does is just it's basically a outline rectangle, a rectangular outline. That's probably the best way to do it, but this isn't needed, so we can actually just get rid of this. Those are more intuitive. But now inside of our weekly video game, we have to add those. Health bar. Health bar controller. And inside of our scene. So here is kind of a issue that we have. We want to attach the game object specifically to something. So there's a couple of ways we could do this. Normally in Unity, for example, what we could do is we could have a public variable and then just drag and drop that variable. But we need some way to be able to get that game object, for say, to actually drag and drop it, which we don't really have a way other than find game object. Well, the issue that happens or kind of arises when we want to so I'll give an example instead. Say we have 50, or let's say we have 10 enemies inside of our current scene. If we use find enemy or find game object and then filter it based off of enemy, it'll give us an instance of one enemy, but we don't know the enemy. So one way to do this is inside of player game object, inside of our constructor, we can say engine.currentScene instantiate. And just like how we instantiate over here, we do a new health bar object, new health bar game object. And then we call this, instead of for our health bar game object, then we call, let's say, 20 and 20. So what this is doing is instead of probably misspelled something. Yeah. Let me fix this first and see. And then what is the issue? Hip engine. Those are current scene undefined. Okay, then we can do it this way. Rather than doing this, what we could do is we could just change this to game object. Game object. We don't need entity anymore. This is probably the correct way to do it, though. Anyway, so then we don't need this. We don't need this. So then inside of our scene, and then inside of here, game object. I don't understand why this. Is it because the scene is undefined? No, that's go to my engine. Go back to my player game object. Hmm. I'm trying to do this the correct way, but we can do it this way. So inside of we'll do it this way instead. So inside of instantiate, what we want to do instead is we want to return something, and we want to return the game object. What this means is kind of twofold. Now we have access to all these game objects, so now we could say player game object equals this, and now what we can do is now we can do this dot instantiate new health bar game object, and we'll need to add back the entity code. There, comma. And inside our health bar controller, we have an entity, and then this dot entity. And then what we do is then inside of our scene, in our main scene, what we can now do is now just say, hey, use this player game object as the entity, and then use 20 and 20. Again, I'll probably go through this and refine it for next week, just to make sure that we do it the correct way. But before we do that, let's also debug. Game object is not defined. Trying to spell it inside of our scene. And then player game object. Oh, we have to do let. And now we have our health bar. And now the way we can check, is it magic? HP, then current HP. Yeah, let's flip these. So it's current HP, then max HP. And then so now if we do 10 HP, now it's at 50% health. If we do add 50%, if we do 1 HP, it's a little smoother. Now if we do 23 HP, it isn't centered anymore because we're not, that's going above our 20 or max 20. So we could do something about that later, but now if it's 12, it's a little bit more than half. If it is 20, it is max. Obviously then, for collisions, what you could do is if colliding with the enemy, you adjust the health bar. You would have to go, so now here's the kind of second issue with doing this, is that there's no connection between player game object and instantiate. So when you collide with something, you would have to search through health bars to match with the player, to see if the entity is the player, which isn't good. But the way around that, there's a couple ways, I think, is inside of our health bar game object entity. What we can do is inside of our player game object, specifically player controller, we would want yeah, I'll have to also get back to you on that as well. Because there's a couple issues with how we currently do it. What should happen is that you attach one game rather than, say, for example, having a separate game object and then attaching that game object to the same position, what you could do, this is probably the best way to do it actually, is rather than doing max HP and current HP, what you want to do is inside of start, you want to keep that stuff that trapped inside of the entity. So what you do is this dot max HP equals this dot current HP equals, and what we do is inside of component we would say health pool controller.js class health pool controller and component, and you would do a constructor. No, not constructor, it's a component, so it is start and update. And all you would do is you would set current HP, max HP, and then you don't even need to start an update, you just need to be able to set it. And then inside of health bar controller, what we would do is we would do entity dot find component health bar, no, health pool controller dot HP current HP. And then what this could do is I need to then go into here, right here, there. I need to do this and then do health pool controller. Let's see what's the issue. Component is not defined. Yep, I spelled that one. Did I spell that? Yep. Inside of game object, we want to. Oh, it's a get component. Component. So in our host. And inside of our health pool controller is max HP and current HP. Okay. So then when we add this, we would also need to go into our player game object, and we would need to add a this.add component, new health pool controller, where we have a max HP is 20, and then current HP is 20. Is it strong now, which is good. We don't need platform. We don't need player. We don't need fast. Let's reset this. Let's go to source, and let's go to health bar controller, and then let's look at our start. Just make sure it's getting the correct stuff. So entity.get component health pool. So it's saying max HP is undefined, but current HP is defined. For health. Oh, it's because we're still doing. We still want to keep max HP, current HP, but we don't want to, inside of our health bar game object, do this. Nope. Because max HP is still undefined. I just do like a spelling mistake. And the health pool controller, their game object. Yep, I did. Okay, so now, well, this is better because now you can actually communicate. So now say you want to adjust your HP to be 10 instead and adjust it, or you increase your max HP to 25, adjust it. But now the issue is that you're still two separate game objects, but this is a way better structure than what it was previously and what I had intended to implement, because now you can actually communicate with the game object instead of having to find the game object associated or find the health bar associated with the game object. So now you don't have to go through and find the health bar. You could just find the game object, adjust its health pool controller, and then boom. And then one final thing you could do, which is something very similar and very easy to do now, is that, say in our health pool controller, we could say if we want to do a min, I think it's called math.min one and this. So now what we do is over health. So say you get over health for something. You could always add a separate thing of over health, or say you heal 5 HP and you can only heal 2. You want to have something like blue, for example, be like a shield or something. What you could do is first you need to get your math.min and make it 1 comma this health percent, because if your health percent is above 1, then it'll go to 1. If it's not, then it'll go to health percent. And you would say something like if this health percent is greater than 1, we just do another CTX fill. This time it will be blue. And it will be, so we would do math.min, or we would do 1 minus, or this health percent minus 1. So now if we go to our health pool or player game object and say we have a current HP of 40, let's do 5. Oh, that's current HP, so sorry, it would be 25. So now if we have 25 HP, then we can do max of that. And then now in the other thing we can do now is do we want to do a math.max. This is so that if we do health percent minus 1, we want a maximum of 2 health percent. So it'd be 2 comma. Okay. So say we have a max of 20 HP and we get 60 health. We don't want it to be an infinite thing, because what will happen is that it'll just keep on getting bigger, bigger, bigger. The blue lines bar specifically, and then it'll just break. It will just break the game because it just won't look correct. So we want to. So then for, I think, blue HP, we should have it so it can only fill up to your health bar as over health or shield or whatever you want to call it. And what you can do is you just fill it with blue, and then what you do is you do your math.min. So you take your minimum of your 2, and then your health percent. So say your health percent is 3, you'll only take the 2, and then you subtract 1 from it. Say your health percent is 1.5, it will just add 0.5 over health. So now no matter how much HP you have, so now say we have 21 HP, that is not correct. So we don't want to scale it between 2 and 1, we want to scale it between. So yeah, what we could do actually is this dot health percent minus equals 1. And then we could do the exact same thing. Or you could do this actually. Let's actually see. So we have a little bit of blue, And now if we go back to, and then do 40, it should be that. But if we do 100 of current HP, it should also say it that. Yep. So if we do 30, it should be halfway through. Yep. Okay. Now we have over health. But yeah, there's a lot of things you could do with this now. Say you want shield. What you could do is you could just type in shield. And inside of our health pool controller, now you have a shield. And that shield could be purple. And then what you could do is say in our health pool, what you do is you just paste this, have purple, and then adjust the numbers to have purple for shield. So there's a lot of ways to actually really expand on this. Kind of just depends on how you want to do it now. But hopefully this is a good base system to actually allow you to kind of do whatever you really want with your HP and pool and stuff like that. It's just the only downside is you're going to have to manage when you instantiate a player game object or a player game object, you first have to get that player game object. We don't need this anymore. We first need to instantiate that player object. Then return that player object and then instantiate the health pool for that game object. And then make sure you have a health pool controller component attached to that game object you want the health bar to. This is kind of a inverse way to do it. There's probably a way to do it. So instead of inside of health bar game object, you could probably do, so say for example, instead of doing this dot, you could do entity.add component health pool controller, but then the health pool, so you don't have to do it like that, but it doesn't make that much sense to give the max HP and that type of stuff to the health pool rather than the player game object. So again, for both double jump and this, I'll probably talk to Rix to iron out some stuff. But overall, there's kind of two kind of core concepts that can be explored a little bit for platformers. So like jumping and having a jump system, and then having health pools and stuff like that. So if you have any questions, concerns, or comments, you could always email me. Otherwise, it should be good.